This baggage barcode does not contain the suitcase's whole route. Scan it, and the standard workflow gets a 10-digit identity. Both local sort paths stay dark until separate baggage and flight data is linked to that number. Then one path lights. That is how the tag helps find the right plane. At first, that sounds backward. The complete tag visibly shows airport codes and flight information. The obvious answer is that the scanner reads those details from the barcode and sends the suitcase toward its destination. International Air Transport Association guidance separates the two. The standard barcode references the 10-digit bag tag number, while flight details are printed elsewhere and linked through baggage information. So, not the route describes the barcode, not the entire tag. That 10-digit number is often called the baggage license plate number, or LPN. In the standard described by IATA, it combines a leading digit, a 3-digit issuer code, and a 6-digit serial number. The complete number is intended to stay unchanged through the journey and in baggage messages. It is not a promise of permanent uniqueness for all time. For this trip, think of it as the suitcase's durable, machine-readable name. A name can identify something without describing where it should go. Now give that identity a separate operational record. Our fictional suitcase checks in for test flight A to test hub. A baggage system can record a tag number together with an outbound flight, station, time, and other handling data. None of those words appears inside our 10 digits. The record holds the current assignment. The number provides the key that lets a system connect the physical suitcase to it. At the next scanner, the bars yield the identity again. The local system can use linked flight and handling data to resolve what happens here. One current commercial example uses baggage source information, flight allocation, onward destination, priority, and travel class to determine a chute. Our model keeps only the causal core. Look up this identity, return the current leg, then select Local Sort Path A. The conveyor is acting on linked state, not reading test hub from the bars. Now remove the separate record and run the scan again. The sample identity is still readable. The same 10 digits still appear. But no flight, destination, or local path can be produced from the identity alone. Both paths remain unresolved. Restore the record and local sort path. A lights again. This test does not simulate an airport or prove how one operator built its software. It proves the narrow dependency at the center of the story. In this model, identity alone cannot make a route decision. The transfer makes that dependency even clearer. The same suitcase reaches test hub with the same identity, 01234567789. But the retrieved current leg now says test flight B to test destination with local sort path B. The flight changed. The destination changed. The local path changed. The LPN did not. IATA guidance allows records to carry inbound, outbound, and onward flight information, but exact transfer procedures differ. The fixed identity can support a new local decision without containing either leg itself. Routing is not the same as proving that the bag was loaded. Public guidance from IATA identifies acceptance, aircraft loading, transfer, and return to the passenger as 4 core tracking points. Records can associate the bag number with a flight, station, event, or container. These checkpoints help record handling and custody. They do not transform the barcode into an itinerary, and reaching the correct local sort path does not prove the bag reached the aircraft. The local route decision and the later handling record are different events. This is why the printed part of the tag is not decorative. Current electronic tag guidance places destination and flight information in a routing area separate from the numeric license plate representation. If normal data is missing, another reading path may recover useful fields. One current vendor product, for example, uses cameras and optical character recognition to recover a barcode, bag number, destination, and flight number when the corresponding baggage source message is unavailable. That is one implementation, not a feature present at every airport. The physical read can fail too. Optical scanning needs line of sight, so a folded or damaged tag may become unreadable. Possible responses include another scan, OCR, or manual recording. Manual entry is valid, but generally slower, more labor-intensive, and more prone to misrecording. Compatible RFID tags and readers can identify baggage without optical line of sight, but they require supporting infrastructure. RFID is not GPS, and none of these methods guarantees a successful read. They are different ways to recover or record identity and handling data. Real baggage systems do not share one universal diagram. Airports, airlines, handlers, agreements, tag types, readers, messages, layouts, and exception procedures vary. Some workflows rely on optical barcodes. Some add RFID or electronic tags. Some systems can derive a chute from linked flight allocation and baggage data, while a person may use visible route fields during an exception. The defensible idea is narrower. The physical bag needs an identity connected to current handling information before a local system or person can decide what happens next. The small tag's real achievement is coordination. A physical suitcase can pass among airlines, airports, handlers, scanners, conveyors, and people, while the same 10-digit reference remains attached to the journey. Each location needs only the information required for its next decision. The tag is not the brain of the system, and it is not a tracking beacon. It is the shared reference that lets separate systems and people agree which bag they are handling. So how does one baggage tag help a suitcase find the right plane? The barcode supplies a durable 10-digit identity. Linked baggage and flight data supply the current assignment. A local system or person makes the next decision. At a connection, the identity can stay while the next leg changes. Printed fields and exception methods help when normal reading fails. The tag participates throughout, but it does not decide the route by itself. Once a scanner has a number, another hidden problem appears. How can a barcode reveal that one digit was read incorrectly? Next, we will use a different barcode standard to uncover the tiny arithmetic check hiding in plain sight.